and my number ID is MA19050. Today I'm gonna present to you all about the introduction for our experiment 3, that is fluid friction. First, we go to the introduction for our experiment, that is background experiment. First, we have the mass of fluid entering the pipe equal to the mass of the fluid exiting the pipe is the continuity equation. Okay, then we have Newtonian viscosity, which have another name, that is viscosity of viscous fluid. When fluid is flow, laminar or turbulent movement is produced. And then we have called fluid friction, that is viscosity which lower the overall energy in the fluid flow. And then in this experiment, we'll be examining the pressure loss and the heat loss. And number 5, we have the part and fitting for the pipe, include for the distance, pipe bend or elbow, pipe branch, cross section, alteration, and valve and flat. Okay, then we go to our objective of the experiment. That is first to develop a complete fluid flow planning process and highlight key and small losses in several piping systems. Number 2, we have the straight pipe. Main loss must be understood and applied at the basic level. Okay, for the number 3, we have to understanding the mechanism of fluid friction in the pipe.
Very good day, my name is Dineshwaran Lucky Gunasekharan and my matrix ID is MA19091. So now I will continue the fluid friction lab. So now I like to explain the literature review of the fluid friction lab. So what is friction? So friction is the force resisting the relative motion of solid surfaces, fluid layers, and also the material elements which slides on each other. So frictional force is anything which resists motion. The definition of friction or the subject of friction is resisting motion or opposing motion. So if you see, the direction of friction will be opposite to the direction of push or pull. So you can see the photo on the slide. So you could see the frictional force flows or moves opposite to the direction of the push force. So friction is always opposite to the pulling force and the pushing force. So now there are 3 types of friction. First is the dry friction, second is the fluid friction, and third is the lubricated friction. So these is the 3 main frictions which has been taught in mechanical engineering. So we are going to focus in fluid friction, but still I would like to give a small explanation about dry friction and lubricated friction. So dry friction is a force that opposes relative lateral motion of 2 solids in contact. So basically dry friction is what we study in statics and dynamics. So that is basically dry friction, where both medium is solid. Now lubricated friction is where the solid has contact with lubricants. So this is basically lubricated friction. And finally in fluid friction, which we have studied in fluids 1 and 2, like that. So fluid friction is the friction between layers of viscous fluid. So we have studied the relation of friction. So in fluid friction, the friction is called viscosity. So fluid friction is developed between fluid layers. Viscosity is the word used for the internal flow. So you could see that direction of motion, fluid friction every time opposes the direction of motion, no matter in any medium. So a fluid's viscosity is known as the friction. So there are 3 types of frictional fluid laws. The first law defines that the fluid friction increases with an increase in the area of contact between solid and fluid. The second law, fluid friction increases with increase in velocity gradient. And the third law is the fluid having a higher coefficient of fluid friction has a higher value of fluid frictional force. So these are the 3 basic laws. So this is like a recallment of fluid 1 and fluid 2. So these are the factors affecting the fluid friction. First, the nature of fluid, the viscosity of the fluid, the shape of the body, the temperature and the surface area of the body. So this is an extra slide. So now our experiment is based on fluid friction in pipes. So we chose pipe or material 1 and 2 in our lab. So there are many, over 25 material or pipes to study, but we chose pipe 1 and pipe 2 for our analysis. So I would like to explain what happens to the fluid friction in pipes. So when a liquid or gas flows through a pipe, the turbulence develops along the interior of the pipe wall, and the viscous shear stress present in the fluid act to impede flow of the fluid. So due to this impedation, there will be a pressure drop in fluid. So why there is a pressure drop is to overcome the frictional forces. So due to the overcoming of frictional forces, there will be energy lost. So normally there will be energy lost in normally like in fittings, elbows, valves. So these are where energy losses happen due to frictional force. So that's why we study fluid friction, is to avoid all these energy losses and to study and to derive an outcome how to prevent these energy losses in real life. So this is an important equation known as the Darcy equation. The Darcy equation is an equation which forecasts frictional energy losses in pipe. So this Darcy equation is particularly used in pipes to calculate the frictional force, but this Darcy equation is given in H value, H loss. So H loss is something like energy loss, where the frictional force can be determined by this equation. So Darcy equation is based on the velocity of the fluid and the frictional resistance. So that's all for now. Thank you.
Hello everyone, my name is Madhavan son of Sivaraman, metric ID MA19090. Today I would like to talk about metrology part of our experiment, which is fluid friction for experiment 3. So let us look on the apparatus for this experiment, especially for the device and tapping. Device we got many for this experiment, but we will use especially for the gate valve, block valve and also ball valve, and we also having the tapping point for the before and after. So as we can see, this variety of pipe frictions is actually gives us the overall view of this experiment, and also the manometers for us to read the before and after values. So this is the procedure of our experiment. First of all, we need to set up the apparatus as shown in the figure above accordingly, like this. And then we must choose 3 pipe flows such as gate valve, block valve and ball valve. Then we should fix the hose connection from pipe until the manometer. Thirdly, open the main valve pipe source and regulate the water level to read the maximum and minimum value first. Fourthly, select the minimum value and proceed by taking the value of manometer corresponding to the inlet and outlet of 3 pipe flows. Fifthly, measure time taken for the volumetric flow to reach 5 liters using a stopwatch. And finally, we will repeat step 4 till step 5 for midpoint and maximum value. So basically we will start from the minimum value and then we continue the same procedure from 4 to 5 for the midpoint and maximum value. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hi, MA19119 Muhammad Iqmal Haikal bin Rahim. So now I want to explain about result and graph for our experiment. For velocity of flow in the pipe, we use formula V equal to 2 pi R over T, and the head loss we use formula FL V square over D2G. So this is length of pipe, we get 0.8 meter. PVC pipe internal diameter we get 0.02 meter, and PVC thickness D we get 1.5 millimeter. And the friction vector F we get 0.02. For your information, the friction vector we use the general friction vector is 0.02. So first of all, when we run the experiment, we just use the 5 liter water in this experiment. So this is a table for valve turning. At the maximum, as you can see, there is a different for pressure before and after. And we use the valve type get globe and ball. The taken for this valve, we get 30.42 seconds, and the velocity in the pipe we get 4.6820 exponent negative 3 meter per second, and head loss we get 8.9383 exponent negative 7 meter. So for R is the radius. Radius we calculate use the diameter 0.02 over 2 to get the radius. Next, this is the valve turning in medium open. You can see to the different pressure for before and after. For this medium open, we get time taken is 60.26 seconds, and velocity of flow in the pipe we get V equal to 3.8642 exponent negative 3 meter per second, and the head loss we get 6.0885 exponent negative 7 meter. The valve turning at minimum open, the time taken to water to fully in the tank is 73.12 seconds. The velocity is 8.530 exponent negative 3 meter per second, and the head loss we get 3.0108 exponent negative 6 meter. So lastly, I want to show you the graph we get. This is a graph heat loss vs velocity. At the x-axis is the velocity meter per second, and the y-axis heat loss meter per second. So at the second velocity, the second velocity is decreased when the head loss decrease, while the last velocity is increased when the head loss increase. So that's all from me. Thank you.
My name is Muhammad Daniel Bizkifli. I will be explaining for the discussion for this experiment by answering the question from the lab sheet. Okay, the first question is, what is the relationship between flow speed and head loss? Okay, to answer this question, we need to refer to this head loss equation first. Okay, from the formula, it shows that the head loss is directly proportional to the squared velocity. So we can conclude that if the flow speed increases, the head loss will also increase. But if the velocity is double, the head loss will increase by a factor of 4 because the head loss is directly proportional to the squared velocity. The next question is, what would happen to the head loss if the length of the pipe is increased? Okay, from this equation, we can see that the length of pipe N is directly proportional to the head loss. So the head loss will increase if the length of pipe is increased. Okay, next question is, what would happen if the head loss? What would happen to the head loss if the diameter of the pipe is increased? Okay, from the equation you can see that the diameter is inversely proportional to the head loss. So if the pipe is increased, the head loss will decrease. The next part of the equation are the pipe elbow loss coefficient and equivalent length. Okay, so the first question is, what is the relationship between the flow speed and the head loss? Okay, to answer this question, we also need to refer to the equation. Okay, so the head loss is directly proportional to the V squared. So if the flow speed is increased, the head loss will also increase. The next question is, what is the connection between elbow and bend in terms of its turning radius, head loss and loss coefficient. Okay. To answer this question, we need to know what happen if the water flow through the bend or elbow in the pipe. Okay. When the water flow through a bend or elbow, it will create loss pressure because of the friction and the momentum change. If the bend is too large, it will create a spiral flow eddy, which you can see from the picture. The spiral flow in the pipe will cause the flow pressure to drop and the velocity to drop. Okay. The factors of this happening are the Reynolds number and the bend angle. The higher the turning radius will increase the pressure drop in the pipe, which is the head loss. Okay. The next question is, what is the conclusion can be made considering elbows and bends in the term of its turning radius and equivalent length? Okay. So we can conclude that from my earlier explanation that the turning radius is directly proportional to the head loss and the loss coefficient. So if the turning radius is increased, the head loss will also increase. For the conclusion of the experiment, we can conclude that we obtain an understanding of the fluid friction phenomenon in the pipes and the major losses in the pipes, specifically on how different types of valves and different types of velocities of the flow in the pipe affect the major losses. From the experiment, we also get to see that using valve creates obstruction in the flow path and causes pressure to drop, and how much the pressure drop difference between using gate, globe and ball valve. We also learned that the velocity of the flow in the pipe will cause an increase in the head loss. Hence, the experiment's objectives are achieved as mechanic of fluid friction phenomena in the pipes, and the basic knowledge of major losses in straight pipe is understood. The parallax error exists in the experiment in the data collection process, and countermeasure needed for more accurate results in the future. That's all from my group. Thank you.